Hello students, in this video we'll discuss future value calculations with annuities due and annuities immediate. So let's recall that we have annuities due. So what is an annuity due? An annuity due is a stream of payments, we've learned about this in previous videos, that starts at time 0 and ends at time n minus 1. So annuities due, you get $1 here, $1 here, $1 here, all the way down to $1 here, and then the payments stop at time n minus 1, okay? And so we've recalled from a previous video that the present value of these things is A double dot NI, and that's 1 minus nu to the n over D. What I'd like to do now is I'd like to find the accumulated value at time n. That's a present value, so let's find the accumulated value. The accumulated value at time n is going to be what? Well, this 1 at time 0 has n years to accumulate, so that's going to be a 1 plus I to the power n. This 1 over here at time 1 has n minus 1 years, all the way down to this 1 at time n years, which has exactly just 1 year to accumulate. 1 plus I, so that's the accumulated value. So this is a geometric progression. I'm going to pull out 1 plus I. And then I'll have a 1 all the way down to 1 plus I to the power n minus 1 over here. Excellent. Now that's a geometric progression, so this is 1 plus I. And then this is going to be a 1 minus 1 plus I to the n over 1 minus 1 plus I. Okay. So of course the denominator over here is just going to be a what? The denominator over here is just going to be an I with a negative sign, so I'm going to flip everything. So this is going to be a 1 plus I times the quantity 1 plus I to the power n minus 1 over I. That's our formula. And so now let me remind everyone what the discount rate is over here. So the discount rate D, recall that our rate of discount is I over 1 plus I. Therefore, 1 over D is exactly just equal to 1 plus I over I. So I have this factor over here of 1 plus I over I. That's exactly just 1 over D. So the annuity, the accumulated value is given by the following formula. I'm going to have an S double dot for due. The double dots are for due. Remember, dot for due, D for discount is going to be what? This is NI. Is going to be equal to 1 plus I to the power n minus 1 over the effective rate of discount. So that's our first formula. S double dot NI is 1 plus I to the power n minus 1 over the effective rate of discount. Let's switch the script to the annuities immediate. So what are annuities immediate? For annuities immediate, the stream of payments starts at time 1 and ends at time n. So here's n minus 1, here's 0, here's 1, here's 2, here's 3. You get $1 here, $1 here, $1 here, $1 here, and $1 here at the final time n. And so let's do the accumulated value. So what's the accumulated value? The accumulated value at time n is going to be this 1 over here at time 1 has n minus 1 years to accumulate. And then all the way down to what? All the way down to that $1 time n. At time n, that $1 is just $1. So at time n, this is going to be a $1. Now I can use the same exact formula over here, and I don't have to actually put this 1 plus I. What I get is exactly 1 plus I to the power n minus 1 over I, just by replicating this formula over here. So what this expression over here is called is this is our S no dots for immediate. So this is S and I, the accumulated value of the stream of payments of $1 every year at the end of the year, is exactly equal to 1 plus I to the power n minus 1 over I. And these are formulas that we use over and over again, either the accumulated value or the present value, where you're going to use these accumulated value formulas if we're going to be pricing things at time n, and we use the present value factors if we're going to be pricing things at time 0. So when we do things like bond calculations, loan calculations, premium calculations, we're going to have to either decide if we're going to do things at time 0 or at time n. We use the A's at time 0 and the S's at time n. Thank you very much.